Okay, and welcome back to a review of Chapter 9. In this video, we're going to be focusing on the rational functions, how we can graph them, how we can identify asymptotes and intercepts. So let's begin with our first problem. Here we're trying to graph f of x equals 4 over x plus 3. One of the easiest things to find out first in a rational function is the vertical asymptote. Vertical asymptote occurs when your denominator equals 0, right? So you set the denominator equal to 0, so we know that x is equal to negative 3. Okay, so that is our vertical asymptote. Okay, VA for short. So what we'll do next is we'll try to gather points around the vertical asymptote to help dictate how we're going to graph this function. Okay, so if we set up our basic graph, x-axis, y-axis, x equals negative 3. So at negative 3, we have a vertical line. I like to draw the asymptotes with dotted lines. So this is like the area that the function cannot exist, right? If we put a negative 3 in there, we get 4 over 0. We have a divide by 0, which we know cannot happen. Okay, so now we're going to try to focus on what's happening around that vertical asymptote. Okay, so what's happening at negative 4, negative 5, maybe even negative 6. Right, what's happening at negative 2, negative 1, 0. Okay, so we set up our XY table. All right, so let's set it up. We have negative 3, so 4, 5, and 6. So let's do negative 6, negative 5, negative 4. Negative 3 we're skipping over because that's our vertical asymptote. Negative 2, negative 1, and 0. Now we just plug in to our function. Okay, plug in negative 6, 4 over negative 6 plus 3, 4 over negative 3, so that's negative 4 thirds. 4 over negative 5 plus 3, that equals 4 over negative 2, so reduce it to negative 2. 4 over negative 4 plus 3, so that gives us 4 over negative 1, so negative 4. Okay, let's plug in negative 2. 4 over negative 2 plus 3, so that's 4 over 1, positive 4. 4 over negative 1 plus 3, so that's 4 over 2, so result of 2. And then 4 over 0 plus 3, so that gives us 4 thirds. Okay, so now let's graph these points. Let's see, we have 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we have negative 6, negative 4 thirds. Negative 6, negative 4 thirds, a little bit past the negative 1. Okay, negative 5, negative 2. Negative 4, negative 4. Okay, and then for negative 2, positive 4. Negative 1, positive 2. 0, 4 thirds. Now, we need to zero in on the horizontal asymptote. So to make this a little more clear, we have to pick some extreme values going towards the left and going towards the right. Okay, I like to pick some rather extreme values, kind of like, let's see, going to the left, I like to pick negative 100. Going to the right, I like to pick positive 100. Okay, so let's plug these in. And this will help us in terms of narrowing down the, the horizontal asymptote. Okay, so if we have negative 100, then this will be 4 over negative 100 plus 3. So 4 over negative 97. So if you think about the value of negative 4 over 97, that would be something very close to 0, right? It's going to be something very close to 0. It's on the negative side of 0. Okay, so it'll be something along the lines of maybe like this. Okay, not quite 0, but getting closer to 0. Okay, and then on the plus side, 100, so we would have 4 over 100 plus 3. That's 4 over 103. So that'll be something very close to 0, but on the positive side of the x-axis. Okay, so something along the lines of, say, here. Okay, now we would have to understand what happens as we get closer and closer to vertical asymptotes, which you'll notice the trend here would be to go like this. And then if you want to be a little more specific, you could plug in points between 0 and negative 1. And then same thing going on the right side. We see that this would go closer and closer to 0 as we go farther out. And then this is going to follow our vertical asymptote and get closer and closer to that vertical asymptote as we get closer and closer to x equals negative 3. Okay, so we will notice we have a vertical asymptote, x equals negative 3. Horizontal asymptote, so now let's fill that in. Okay, the horizontal asymptote would be our x-axis, y equals 0. Okay, so y equals 0. Okay, intercept-wise, x-intercept looks like we won't have an x-intercept, right? Because we'll never have this function equal to 0. But y-intercept wise, if we plug in 0, which we did already, y-intercept would be 0 4/3. So that would be our y-intercept. Okay, x-intercept, that would be a NA. All right, so that's about it for this one. Let's take a look at our next one. Okay, the function f of x equals 2x over x minus 1. Again, easiest place to start is the denominator. Set that equal to 0. Okay, so x minus 1 equals 0. Add the 1, so x equals 1. So that's our vertical asymptote. X equals 1. Okay, we can go about and try to graph it now. Okay, and we'll put in the dotted line for the vertical asymptote. Okay, so now we're going to work both sides of that vertical asymptote. Okay, so we'll have x, y axis. So we'll have, going to the left of 1, we have 0, -1, -2. So let's do that. -2, -1, 0. To the right of 1, we have 2, 3, and 4. Okay, now we'll do the same thing. We'll plug in our values for x into the function. So we have 2x over x minus 1. So for -2, we have 2 times -2 over -2 minus 1. So that's -4 over -3, so positive 4/3. -1, 2 times -1 over -1 minus 1. So -2 over -2, so positive 1. 0, 2 times 0 over 0 minus 1. 0 over -1, so 0. 2, 2 times 2 over 2 minus 1, so 4 over 1 is 4. 3, 2 times 3 over 3 minus 1, so 6 over 2, so that's 3. And then 4, 2 times 4 over 4 minus 1, so that's 8 over 3. Okay, so let's graph this. All right, -2 4/3. So -2 4/3, so it'll be a little bit above 1. -1 1, -1 1, and then 0 0. Right, let me change color here so it stands out. 2 4, 2 4 would be up here. 3 3 here, and then 4 8/3. So 8/3 is a little bit under 3. Okay, so now remember the last problem I asked you guys to pick some extreme values, or I should say we did some extreme values just to see what the horizontal asymptote would be. So I'll plug in -100 and positive 100. See what's happening. So for -100, that would be 2 times -100 over -100 minus 1. So -200 over -101. That'll give us a positive 200 over 101. So if we made that a mixed number, that would be 1 and 99 over 101. So something very close to 2, right? So 1 and 99. Okay, for 100, let's do the same thing. So 2 times 100 over 100 minus 1. 200 over 99. So then this will turn out to be definitely over 2. It's a matter of 2 times 99 is 198. 2 more. So 2 and 2 over 99. Okay, so we kind of see what's going on. In fact, I'll stretch this vertical asymptote a little bit more. Okay, so in the big picture of things, on the negative side of x, we're approaching 2, but from the underside of 2. Notice it's not quite 2, it's close to 2, but from the bottom, right, from the underside of 2. Okay, so this will go like this. Okay, and then going towards the right, okay, notice we'll do this. And then as we go towards positive infinity, the function's approaching 2, but from above 2, right? It's a little bit above 2 there. So it'll approach 2 from the top. Okay, so that means now we've determined our horizontal asymptote. Okay, so the horizontal asymptote would be y equals 2. Okay, and then other points of interest, we had one point that is a x-intercept and a y-intercept. Okay, so 0, 0, x-intercept and the y-intercept plays both roles. And that's about it, right? No other x-intercepts as we could identify. And that's about it. Okay, let's take a look at our next one. Okay, negative 3 over x squared plus x minus 2. Whenever you have a function that's a rational function, you want to make sure that denominator is factored, and then from there we set those factors equal to 0. Okay, so the x squared plus x minus 2, we can write that as, what can we do there? That's a factorable quadratic, right? That's going to give us plus 2 and a minus 1, right? X plus 2 and an x minus 1. Okay, so that means we have two vertical asymptotes here. Just set each factor equal to 0. So vertical asymptotes, x equals negative 2 and x equals 1. So now we have to keep track of the points that are around those two vertical asymptotes. Okay, so let's draw our graph. Okay, so let's draw our two vertical asymptotes. X equals negative 2 and x equals 1. Okay, so now we're going to keep our focus around those points. Okay, so around negative 2, we could go out to negative 3, 4, 5. get the 2 points in between, negative 1 and 0. And then we could do points 2, 3, and 4. Okay, so let's make a table. -5, -4, -3. In between are going to be -1 and 0. After that last one is going to be 2, 3, 4. Okay, so let's plug these in. -5. So we're going to plug into the factored version, make it a little easier. So we have -3 over -5 plus 2 and -5 minus 1. So that's -5 plus 2 is a -3. -5 minus 1 is -6. We can cancel the -3's. So that'll be -1/6. Is that right? -1/6. Okay, next, -3 over -4 plus 2. -4 minus 1. -4 plus 2 is -2. -4 minus 1 is -5. It's -3 over 10. -3, so -3 plus 2. And -3 minus 1. -3 plus 2, -1. -3 minus 1 is -4. That's a positive 4, so -3 over 4. Okay, -1. So that gives us -3 over, that's 1 times -2, so -2. That's a positive 3/2. 0, 0 plus 2, and then 0 minus 1, -3 over 2 times -1 is -2, so that's a positive 3 over 2. I'm looking ahead. Those 2 points in the middle there, they're both giving us 3/2. So we might have to do some additional points getting closer to the vertical asymptotes to figure out which way it's going to go. Okay, right now they're both at 3/2. So -1 3/2, 0 3/2. So they're both, at the same horizontal. We want to see which way they're going to bend, which way they're going to turn. So we'll probably have to insert new points here and here. All right, no problem. We could do that. Let's finish it up and then we'll worry about those points. 2, -3 over 2 plus 2, 2 minus 1. That's 4 times 1, so 4. So -3/4. 3, that's 10, so -3 over 10. And then 4, That's 6 times 3, so 8. Is that 6 times 3? That's 18. Which reduces to negative 1/6. Okay, let's fill in those points now that we mentioned earlier. So between negative 1 and negative 2, we could plug in negative 3 halves. And then between 0 and 1, we could plug in 1/2. Okay, and remember, the reason why we're adding these additional points is we want to see which direction this is going to go. Is it going to go up this way or is it going to go down this way? So let's plug those in. Negative 3 halves. So negative 3 halves plus 2, negative 3 halves minus 1. This gives us 4 halves. Minus 3 halves is 1/2. Negative 3 halves minus 2 halves is negative 5 halves. Multiplying together, that's negative 5/4. Okay, negative divided by negative is positive. So then we have 3 divided by 5/4, or 3 times 4/5. So that would be 12/5. So in other words, 2 and 2/5. So 2 and 2/5. Okay, let's do the same thing with the 1/2. Plug the 1/2 in there. 1/2 minus 1. 1/2 plus 2, that's 2.5, which is 5 halves. 1/2 minus 1 is negative 1/2. That gives us negative 5/4. Oh, and that gives us the same thing. So 2 and 2/5. Okay, and then remember the big picture item we always talk about. We're going to go to, let's see what's happening, extreme on the left, negative 100. And then we'll plug in positive 100. So negative 100 so that gives us negative 3. And then negative 100 plus 2, negative 98. Negative 100 minus 1 is negative 101. So 98 times 101, that would be positive, and then this would be a negative on top, 9898. Okay, so that'll be a value, it's a negative value, but something very close to 0. So negative 3, 9898. And then for 100, plug it in. That's 102 times 99. So 102 times 99 should be 10,098. Okay, so let's graph it. We have our points with us. So we'll have the negative 100. Notice that'll be something very close to 0, but it'll be on the underside of 0. So something like over here. Okay, and then our points, negative 5, negative 1/6. Negative 4, negative 3/10. Negative 3, negative 3/4. Okay, and then we had the extra points. Negative 3, 2, and negative 3/2. So that'll be here. Negative 3/2. 2 and 2/5. So 2, a little bit above the 2. We did the 2, 3/2. And then half, 2 and 2/5 will be about here. Okay, now we know what that's doing. And then on the plus side of 1, we have 2, negative 3/4. 3, negative 3/10. 4, negative 1/6. Okay, and then our really large point, 100, negative 3 over 10. So that's going to be a very small number. It'll be negative. So it'll be very close to 0, in fact, right, on the negative side. So it'll be like that. Okay, so let's fill in the gaps now. This will be like this. Okay, in between here we'll have this. And then over here we'll have okay, so horizontal asymptote, okay, appears to be 0. All right, we're approaching 0 from the bottom. So horizontal asymptote would be y equals 0. Okay, any x-intercepts? Checking. No x-intercept. Y-intercept? Yes. Right? Y-intercept. Y-intercept would be 0, 3/2. And x-intercept would be not applicable in this case. Okay. So that's about it for this one. Yeah, this is probably one of the more challenging ones where you have to do the factoring, and then now you have two vertical asymptotes, so you have to figure what's going on around the two vertical asymptotes. Okay, but it's a good example in terms of what to expect. Okay, so that's about it for the review video. Okay, have a good day, have a good night. We'll see you soon.